This video is about magnetic forces. After working through this assignment, you should be able to relate the magnitude and direction of the magnetic force on a moving charged particle in a magnetic field, identify the component of the magnetic field that exerts a force on a moving charged particle in a magnetic field, and relate the centripetal magnetic force acting on a charge to the motion of the charge traveling in a circle, as in a cyclotron. To get the most out of this video, you should have a solid understanding of Newton's second law, where a net force acting on a mass is equal to the mass times the acceleration, and for a particle in circular motion, the centripetal acceleration is the particle's speed squared divided by the radius of its circular path. A magnetic field, like that produced by a permanent magnet, is a vector field having a magnitude and direction at all points in and around the magnet. Magnetic field lines are closed loops that, when outside the magnet, point away from the North Pole and towards the South Pole. Within the magnet, the magnetic field lines continue from the South Pole towards the North Pole. If you bring in another bar magnet with its South Pole facing the North Pole of the first magnet, you can produce a uniform magnetic field between the poles that points away from the North Pole and towards the South Pole. And if there's a charged particle within that field, the particle may experience a magnetic force due to the magnetic field. The magnetic force is equal to the magnitude of the charge, Q, times the speed of the charge, times the strength of the magnetic field, B, times the sine of the angle between the velocity and the magnetic field vectors. If the charge is at rest in the field, then there's no magnetic force in the charge. In order for there to be a force, the charge must be moving within the field. But the direction that charge moves in the field affects the magnetic force on the charge. If the charged particle's velocity is in the same direction as the magnetic field vector, then the angle between the velocity and the field is zero, and there's no force on the particle. If the charged particle moves in a direction perpendicular to the magnetic field, then the angle between the particle's velocity and the magnetic field is 90 degrees. And since the sine of 90 degrees is equal to 1, the force is equal to the charge times the speed times the strength of the magnetic field. Consider a charged particle that carries positive 4.92 nanocoulombs of charge and moves through a 2.21 millitesla magnetic field at an angle of 53 degrees to the field. If the particle experiences a force of 4.1 micronewtons, what's the speed of the particle?